Okay, welcome back. When we left off last time, I had asked you to fill out these questions on your own. The first one is, what is the measure of how far an object moved? That's distance. What's the difference between distance and displacement? Well, the difference between distance and displacement is distance tells us only how far an object has moved, whereas displacement tells us both. There's a short clip here I wanted to look at to review speed and velocity.
Welcome to the physics unit. Physics is the study of motion. But what is motion anyway? Motion is a change in position. To know if you're moving, you need a frame of reference. A good frame of reference is an object that is not moving. For example, you know this plane is moving to the right by comparing it to the items on the ground, like this tree. A frame of reference is whatever you're comparing a moving object against.
There are three ways to measure motion: speed, velocity, and acceleration. You can measure speed with a speedometer, but to measure velocity, you need a speedometer and a compass. To measure acceleration, you need a moving speedometer needle or compass needle. Let's use the roller coaster as an example. To measure speed, you want to know how fast it travels. Velocity measures how fast or slow and in what direction. And acceleration measures how quickly or slowly it's speeding up, slowing down, or changing direction. In everyday language, speed and velocity are used interchangeably. But for science class, we need to know that technically, velocity includes direction. Watch out for this on quizzes.
Acceleration is a change in velocity. Usually people only think of this as speeding up, but don't forget that acceleration could also mean slowing down or changing direction. Because remember, velocity isn't just your speed, it's your speed and your direction. Let's try some examples. Here we have Mickey. He is traveling at 20 meters per second. Anytime you see that m/s, you say that as meters per second. What do you think this is a measure of? His speed, velocity, or acceleration? Did you say this was Mickey's speed? If you did, you're right. This tells us how fast Mickey was going without his direction, making it his speed.
This is Bert. He's traveling at 30 meters per second, up, down, and around. Is this Bert's speed, his velocity, or his acceleration? If you said that this was Bert's velocity, you're right. This is because it includes both his speed and his direction. He also happens to be accelerating because his direction is changing, even though his speed is not.
Let's try one more example. Emily is about to gain 2 meters per second of speed every second as she heads downhill. Is this an example of her speed, her velocity, or acceleration? If you said this is an example of Emily's acceleration, you're right. It is because it shows how much speed she's picking up each second and in a particular direction. If you're feeling a little confused, we're going to go over this more tomorrow in class, so make sure you write down any questions you have. Whoa!
Random Panda.
Okay, so a displacement also tells us how far and in what direction an object has moved. Define speed. Speed is how far an object moved per unit of time. Speed always constant? No. It's very rarely constant. What is speed usually doing? Speed is usually changing. Appearances compare and contrast average speed and instantaneous speed. Average speed is the total distance an object has traveled divided by the total time for the trip. The instantaneous speed is the speed of an object is traveling at any given instant. What's similar about both use distance and time to tell us how fast an object is moving. What is velocity? Velocity tells us the speed and direction of an object moving. So it's its displacement divided by time. Just remember, displacement is how far it went and in what direction. Displacement is speed and direction. Okay, in this next section, we're going to be calculating speed. So we're going to use the triangle that we learned earlier in the year in the first semester. Whenever you use one of these triangles, you need to put the equation in it. And after you get the equation in it, then you're going to fill out the parts of the triangle that we know. And you're going to use the triangle to help you do the math. The first step in any word problem should be to identify what the question is asking you. So here's our equation. Our equation says speed equals distance divided by time. Over here, we see the d divided by the t. So we're going to go ahead and put this part in the triangle now. This part of the triangle represents the divided by bar, the fraction bar, just like the equation. So we have d divided by t. And then we're going to put the third variable, s, in the box that's left. If the numbers are next to each other on the bottom of the triangle, then we know we need to multiply. If the numbers are up and down, like if we knew b and t, then we would divide because this part of the triangle represents a fraction bar. Okay. Just a quick review of the units. Units for distance, we'd be seeing things like meters or kilometers, which is km, and it stands for kilometers. Time would be things like minutes, hours, and seconds. Speed is going to be this divided by this. Remember, this bar represents a fraction bar. So the speed could equal meters divided by minutes, which I put over here, meters divided by minutes. It could equal kilometers divided by hours. So we could have kilometers per hour. It could be kilometers divided by seconds. So it could be kilometers divided by seconds. Remember, this bar right here represents the fraction bar. Now let's look at this example question. How far will a car travel if the speed is 75 kilometers per hour and it travels for 3 hours? When we read how far, this is a distance question. So we're going to put a question mark where the D is in the triangle. That's what they're asking us to find. That was step one, identify what the question is asking. When we read 75 kilometers per hour, it says speed is 75 kilometers per hour. So that told us the speed. So we're going to put the 75 kilometers per hour where the S is in the triangle. 3 hours is time. So we're going to put the 3 hours where the T is in the triangle. The numbers are next to each other, so we know we need to multiply. Just like in math, numbers are next to each other, meaning you multiply. So we're going to have 75 kilometers per hour, just like what we wrote over here, times 3 hours. The hours are going to cancel out. We have hours on top and hours on the bottom. The only unit that's left is kilometers, and that should make sense that our unit for distance would be in kilometers. 3 times 75 is 225, and the unit for the distance is kilometers. Okay, on this next set of problems, the first thing we want to do is fill out a triangle. So we're going to put distance divided by time and speed in the other box. So we have the STD triangle filled out. And we read the problem: if a runner runs at a speed of 15 kilometers per minute and ran 900 kilometers, how long did the runner run? Well, when they're asking us how long, okay, they're asking us how long did it take. So they're asking us to find the time. So how long is a time question? So we're going to put a question mark where the T is in the triangle. That's what they're asking us to find. How long did he run for? When we read 900 kilometers in the problem, that's telling us the distance. So we're going to put the 900 kilometers where the D is in the triangle. So there it goes. Then we read that he had a speed of 15 kilometers per minute. So 15 kilometers per minute is his speed. So we're going to put 15 kilometers per minute where the S is in the triangle. So we're going to put it right there. Now the numbers are up and down, or top and bottom. So that means we're going to divide. So let's solve the problem. We have the 900 kilometers just like this, divided by the 15 kilometers per minute, which is what we put in the triangle over here. This bar on the triangle is this divided by bar right here. Now, we see on the top kilometers and we see on the bottom kilometers, so we can cancel those. And the unit that's left is time, or 15 minutes. Okay, so it's a unit for time, which makes sense because that's what we've been asked to solve. So now when we solve it, we have 900 divided by 15, which is 60, and the unit that's left is minutes. So it took him 60 minutes or 1 hour to run this 900 kilometers. Jesse rode his bike for 3 hours to get to his friend's house 60 kilometers away. How fast was Jesse riding? Well, they're asking us to find how fast was he going, or Jesse's speed. So we're going to fill out our triangle, put in the speed, distance, and time, and they're asking us to find Jesse's speed, so we're going to put a question mark where the S is in the triangle. We read 3 hours in the problem. 3 hours is a measure of time, so we're going to put the 3 hours where the T is in the triangle. So we're going to put it right there. 60 kilometers is a measure of distance, so we're going to put the 60 kilometers where the D is in the triangle. Now, since they're up and down in the triangle, so we have 60 divided by 3. They're up and down in the triangle or on the top and the bottom, so we're going to divide. So when we go to solve, we have what we wrote right here, 60 divided by 3. That's going to equal, there's nothing top and bottom to cancel, so it's going to be kilometers divided by hours, or kilometers per hour. We're going to pick up here next time, but you're going to solve some of these problems on your own. I hope you're having a great day, and we'll see you next time.